Hard question. A curve have equation y equal to ln phi minus 3x, x less than 503. Normal to the curve at x equal to negative 5, cut x-axis at point P. Find the equation of normal and the x-coordinate of P. So when x equal to negative 5, so y will be ln 5 minus 3 times negative 5. Then it will be ln 20. Okay. And the dy dx will be 1 over 5 minus 3x multiplied with negative 3. So the dy dx when x equal to negative 5 will be negative 3, 5 minus 3 times negative 5. So negative 3 over 20. This is the gradient of tangent. And then the gradient of normal is negative 1 over gradient of tangent will be 20 over 3. So we have the y minus ln 20 equal to 20 over 3 x minus negative 5. Okay. And at P, x-axis y equal to 0. So negative ln 20 equal to 20 over 3 x plus 5. So we have the negative 3 over 20 ln 20 equal to x plus 5. So x will be negative 5 minus 3 over 20 ln 20. Okay, this will be the answer. Okay, so we will have the negative 5 minus 3 over 20 ln 20. Okay, is equal to negative 5.45. Okay, question number 2. Variable x, y are such that y equal to e to the power x over 2 plus x cos 2x. X is in radian. Use the differentiation to find the approximate change in y as s increase from 1 to 1 plus h. So we have the x equal to 1 and then the del x is h. So we want to find the dy dx. This is uv. Y prime will be uv prime plus vu prime. So this will be 1 over 2 e to the power x over 2 plus, okay, x times negative 2 cos 2 sine 2x. Differentiate cos will be negative sine. And then differentiate 2x is 2 plus cos 2x times 1. So this will be ex over 2 plus minus 2x sine 2x plus cos 2x. So the dy dx when x equal to 1 will be the e to the power half over 2 minus 2 sine 2 plus cos 2. Okay, so we have the e to the power of e to the power half, and then this one over 2 minus, I have to change the angle unit to radian, 2 sine 2 plus cos 2. Okay, so this one will be negative 1.41. So we know that del y del x approximate to dy dx. So del y approximate to dy dx times del x. So this will be negative 1.41 h will be the final answer. Okay. Question number 3. Tangent to the curve x equal to 2 meet the y-axis at P. Find the exact coordinate of P. So when x equal to 2, okay, y equal to ln, okay, 3 times 2 square is uh, 4, 12, 12 minus 4, 8, minus 8 over 6, 8 over 6. This one will be 4 over 3. Okay. And then dy dx will be 1 over 3x squared minus 4, 6x. Differentiation of 3x squared minus 4 will be 6x. Minus 3x squared over 6. So this one divided by 2. So tangent, so dy dx when x equal to 2 will be 6, 2. And then 3, 2 square minus 4, 2 square over 2. Okay, so we will have 3x square minus 4 is 8. So 12 divided by 8 will be 3 over 2. And then minus 2 will be negative half. This is the gradient of tangent. Okay, so all we have this 6x over 3x squared minus 4 minus the x squared over 2, substitute with 2, then it's negative half. Yes. Okay, so we have the y minus the ln 8 minus 4 over 3 equal to the negative half x minus 2. Okay, at P y-axis, so meet the y-axis, x equal to 0. Okay, so y equal to this one 0 minus 2 is negative 2 times this will be 1 plus ln 8 minus 4 over 3. So will be ln 8 minus 1 over 3. Okay, exact coordinate of P. So P will be 0 ln 8 minus 1 over 3. Okay, done. So just now this part equal to 0. And then we multiply this and move it here. Okay. Question number 4. A container is a circular cylinder open at one end, base radius r, height h, volume is 1000. Okay. Given that r and h can vary and the total outer surface area have a minimum value, find this value. So we know that volume is pi r square h. So 1000 is pi r square h. So the h will be 1000 over pi r square. And the surface area will be the pi r square plus the 2 pi r h. So pi r squared plus 2 pi r 1000 over pi r squared. So pi cancel, r cancel. So we have the pi r squared plus 2000 r to the power negative 1. So the ds dr will be 2 pi r minus 2000 r to the power negative 2. second derivative will be the 2 pi plus 4000 r to the power negative 3. So ds dr equal to 0. Then we have the 2 pi r minus 2000 over r squared equal to 0. So 2 pi r equal to 2000 over r squared. And then the r cube will be 1000 over pi. So r will be the cube root of 1000 over pi. Okay, so the second derivative when r is 1000 over pi cube root. So this one is the 2 pi plus 4000 over uh, cube root 1000 over pi to the power of 3. So 4 pi, 6 pi greater than 0. This is minimum. Okay. So the value of R will be this, the value of S surface area. So the S will be pi R square plus, so is the pi cube root of 1000 over R square plus 2000 over cube root 1000 over R. So we have the pi x square plus 2000 over x, 2000 over R. When R is the cube root of 1000 over pi. So this will be 439.3775663. So it's 439 cm square. Okay. Question number 5. Find the x-coordinate of the stationary point of this. So we have the uv here. So uv prime plus vu prime. So the dy dx will be e3x 6 2x plus 3 power 5 times 2 plus 2x plus 3 power 6 3e3x. So we can factorize 3e3x 2x plus 3 to the power 5. Then we have 4 plus 2x plus 3. So we have the 3e3x 2x, okay, 2x plus 3 to the power 5, 2x plus 7. Okay. So over here we factorize this e 3x, and then the 6 here is 2 times 3. So we can factorize the 3 here, and then this power 5, we have this is the 2x plus 3 power 5 times the 2x plus 3. Okay, so what left here is 2 times 2 4. Okay, so we have the 2 times 2, then it's become 4, and then the 2x plus 3. So stationary point, that is the dy dx equal to 0. dy dx equal to 0. So we know that 3e3x will always greater than 0. So 2x plus 3 equal to 0. X equal to negative 3 over 2, negative 1.5. So 2x plus 7 equal to 0. X equal to negative 7 over 2, negative 3.5. So B, a curve have equation y equal to fx and have exactly two stationary points. So the second derivative is this, first derivative is this. So when 0.5 and 3 is the stationary point, so use the second derivative test to determine the nature of each of the stationary point of the curve. So we have the f double prime of 0.5 is 4 times 0.5 minus 7. So it's negative 5 less than 0. So it is maximum at x equal to 0.5. So second derivative of 3 will be 4 times 3 minus 7, then is 5 greater than 0. So minimum at x equal to 3. Okay, then C. In this question, all lengths are in cm. Okay. Diagram show a solid cuboid, height h, rectangular base, measure 4x by x, volume is 40. So we have the 4x, okay, 4x times x times h equal to 40, h equal to 10 over x squared. So x and h value, surface area minimum, find the value. So surface area, because it is a solid, okay, so surface area is 2 of the 4x times x plus 2 4x times h, and then we have 2, okay, x times h. So the surface area is 8x squared plus 8 plus 2, 10 xh. So 8x squared plus 10x times 10 over x squared, h is this. Then we have the 8x squared plus 100x to the power negative 1. Okay. So we find the minimum value. So this is s. So ds dx will be 16x minus 100x power negative 2. And the second derivative will be 16 plus 200x power negative 3. So minimum when dx equal to 0, that is the 16x minus 100 over x squared equal to 0. 16x equal to 100 over x squared. So x cubed equal to 100 over 16. So this is x cubed. Okay. So x will be cube root. So x will be the cube root of 100 over, no, cube root of 25 over 4. Okay. So the surface area is this one. Okay. So it will be 8 and then cube root of 25 over 4 square plus 100 over cube root of 25 over 4. So we have the 8x squared plus 100 over x And then this is the cube root of 25 over 4. So this is 81. Okay. So 81.43 cm square. Okay. Uh, 4 only now. 3 decimal place, 3 significant figure. And then the second derivative when the x equal to cube root of 25 over 4 will be 16 plus 200 over 25 over 4. So we have the 16 plus 200 over 25 times 4. Then it's 48 greater than 0. So it is minimum. Okay. Mm, done. Okay. Question number 6. Find the equation of the tangent. So we have the y equal to half tangent 2x plus 7 over 2. So dy dx will be half secant square 2x multiplied with 2. So it will be secant square. So secant square is 1 over cos square of 2x. So when x equal to pi over 8, y will be half tangent 2 times pi over 8 plus 7 over 2. So this is pi over 4. So tangent pi over 4 is actually 1. Okay, so this is 1 here. Okay, uh, then we have the 8 over 2, 4. Okay, so the dy dx when x equal to pi over 8, we want to find the equation of tangent. So equation of tangent 1 over cos square 2 times pi over 8. So we have the cos pi over 4 is this, and then we square it is this, and then 1 over, then we will have 2 here. This is equal to 2. Okay, so we have this 1 over this square, then we have 2. Yes, all right. So we have the y minus 4 equal to 2x minus pi over 8. Okay. Mm. So this is 2x minus pi over 4 is y minus 4. So we have the 2x minus y equal to pi over 4 minus 4. Okay. So expand. Uh, okay. So A is 2, B is 4, C is negative 4. This tangent intersect x-axis at P. So at P, y equal to 0. X-axis y equal to 0. So 2x equal to pi over 4 minus 4x equal to pi over 8 minus 2. At Q, x equal to 0. So negative y equal to pi over 4 minus 4. So y will be the 4 minus pi over 4. Okay, so for this one, we have the pi over 8. So pi over 8 minus 2 negative something 4 minus the pi over 4. Oh, this is positive. So what we have is something like this. So y x 4 minus pi over 4, pi over 8 minus 2. This is p, this is q. So we want to find the length of pq, Pythagoras theorem. So it will be square root of the pi 8 minus 2 squared plus the 4 minus pi over 4 squared. Okay, so square root of the pi over 8 minus 2 square plus the 4 minus the pi over 4 square. So the final answer will be the 3.59 unit. Okay. Question number 7. We have y equal to uv. So y prime will be uv prime plus vu prime. And then the y here is x plus 2 to the power half. So the dy dx will be the x half x plus half over negative half times 1 plus the uh, x plus 2 to the power half times 1. Okay, so this is x over 2 square root of x plus 2, and then the square root of x plus 2, so we have times 2 square root of x plus 2. So this will be the x plus 2x plus 4 over 2 square root x plus 2. Then it will be 3x plus 4 over 2 square root x plus 2. Okay. Find the exact coordinate of stationary point. So stationary point when dy dx equal to 0. So we will have this equal to 0. So we have the 3x plus 4 equal to 0, x equal to negative 4 over 3. Okay. And then the y will be negative 4 over 3, and then square root negative 4 over 3 plus 2. So we have the x times the square root of x plus 2 when it is negative 4 over 3, then it will be this. Okay, exact coordinate. Well, so it will be negative 4 over 3 square root of 1 times 3. So we have the 2 over 3. Okay, then it will be negative 4 square root 2 over 3 square root 3. Then we multiply with square root 3 to rationalize the denominator. Then it will be negative 4 square root 6 over 9. Okay, so the exact coordinate will be negative 4 over 3, negative 4 square root 6 over 9. So we need to determine the natural. So we know that the first derivative is this. This is the first derivative. If we want to find the second derivative, will be difficult. So we what we do here is we have the x and then negative 4 over 3, the dy dx is equal to 0. So 0, negative 1.33, okay, 43. So negative 1.3 and negative 1.4, negative 1.4, negative 1.3. So we have the 3x plus 4 over 2 square root x plus 2. When we substitute with negative 1.4, then is negative. So this is downward. And then when we have the negative 1.3, then it's positive, then upward. So combined, we have this shape. So it is a minimum. Okay. So we will say that this one is a minimum point. Okay. Is a minimum point. Okay. Question number 8. Differentiate with respect to x. So dy dx will be secant square x plus 4 minus 3 cos x. Okay, done. Okay. And then variable xy differentiate. So we have the x equal to 1, del x equal to h. So y is u over v, y prime is v u prime minus u v prime over v squared. Okay, so the dy dx will be the 2e3x multiply 1 over, no, over 2x plus 5 times 2 minus the ln 2x plus 5 multiply with 6e3x and then over with the 2e3x squared. So we will have this 2e3 times 2 over 2 plus 5 minus ln 2 plus 5 times 6e cubed over 2e cubed square. Okay, so this is negative 0.138. Or we have the differentiation of the ln 2x plus 5 over 2e3x when x equal to 1. Yes, same. Okay, so we know that the del y over del x approximate to dy dx. So del y approximate to the dy dx times del x. Then it will be negative 0.138h. That question number 5. So we have the y is u over v, vu prime minus uv prime over v square. So find dy dx when x equal to pi over 3. So dy dx will be the sine x and then 3. So 3, uh, 3 secant square 3x minus the tangent 3x cos x over the sine square. So sine square x. So sine pi over 3. So pi over 3 is 60. So sine pi over 3 is square root 3 over 2. Yes. And then the cos will be half. Tangent is square root 3. Okay. So the dy dx when x equal to pi over 3 will be 3 square root 3 over 2. So secant, no. Wait, this is, no, what we want is the pi over 3, but yeah, yes. So this is the 3 sine pi over 3 square root 3 over 2. So cos pi. So cos pi is the -1. Okay. So cos pi is -1. Okay. So 1 over -1 square is 1 minus tangent pi. So we have the tangent pi is 0. Okay. So 0 times the 1 over 2. And then the whole thing divided by the square root 3 over 2 square. Ding, ding. So we have the 3 square root 3 over 2. Okay. 3 square root 3 over 2. Wow. Um, something wrong. Sine, secant, sine. Oh no, this is sine x. So sine x here we have the sine pi. Sine pi is 0. No. So this is sine x square. 0 square? No. This is correct. Yes, just now this one is the square root 3 over 2 square. Okay. So it should be 3 square root 3 over 2. So we have the 3 sine x over the cos 3x square minus tangent 3x cos x over sine x square when it is pi over 3, 2 square root 3. Oh, well, this is 2 square root 3. 2 square root 3. Tangent 3x, tangent pi is 0. Sine x secant square, no. Secant square 3x. So this will be the 1 over half square. So 4. Okay. So we will have the 3 times 4 over square root 3 over, no, 3 times square root 3 over 2 times 4. 2 square it will be 3 over 4. No, the 3 square root 3. So this is 4 half. Okay. This is half. Half square is half. Is 2. Multiply with 2. Oh, yes. Okay. So this is 3 times 2 over. No, 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 no. Yes. 3 times 2 over square root 3 over 2. Square root 3 over 2. 3 square root 3 over 2 times 2 over 3 over 4. No, this is 4. Half square will be 4. So 3 cancel. And then this will be 2. Never mind. We just use the value in the using calculator. Okay. And then we can check the answer of the d per dx of the tangent 3x over the sine x when x is the pi over 3. 3.4 something. 2 square root 3 is 3.46. Yes, correct. Yes. And then the approximate change. So the x is this, del x is h. So we know that del y approximate to dy dx times del x. So the del x will be the 2 square root 3h. Okay. 3.4, 3.5. So x increase at the rate. So we have the dx dt is 3. So we want to find dy dt. So dy dt dx dx. So this is 2 square root 3 times 3. So this is the 6 square root 3. Okay, that. Question number 10. Y equal to ln sine x plus 3 cos x. So dy dx will be 1 over sine x plus 3 cos x, and then differentiate of sine x will be cos x minus 3 sine x. Okay, done. Find the value of x when the dy dx equal to negative half. So we have this equal to negative half. So we will have negative 2 cos x minus 3 sine x equal to the sine x plus 3 cos x. So negative 2 cos x plus 6 sine x equal to the sine x plus 3 cos x. So 5 sine x equal to 5 cos x. 5, 5. Well, so we have the sine x over cos x equal to 1. Then we have the tangent x equal to 1. X will be the arctangent of 1. Then it's 45 degree or it is pi over 4 radian. Okay. Question number 11. So we have y is this, and then we want to find the dy dx. So we have the y equal to u over v. Y prime will be the v u prime minus u v prime over v square. So dy dx will be the x squared plus 1 and then 2 e2x minus 3 minus e2x minus 3 times 2x and then over uh, over okay this one over the x squared plus 1 square. So we will have the 2e2x minus 3 we factorize, then we have the x squared plus 1 minus 1 minus x. Okay, we factorize 2 the e3x and the e2x minus 3. So we factorize this and then we factorize the 2 here. Okay, so what remain inside will be the x squared plus 1 minus x. Okay, minus x. And over the x squared plus 1 square. Hence, okay, um, given that y increase at the rate of 2 units per second, okay, so we have the dy dt is 2 exact rate when x equal to 2. So x equal to 2. So this is dy dx. Okay. So the dy dx when x equal to 2 will be 2e 2 times 2 4 4 minus 3 is 1. And then we have the 2 square plus 1 minus 2 over the 2 square plus 1 square. Then this will be the 2e times 4 plus 1, 5, 5, then 3. Then this is 4 plus 1, 5, 5 square is 25. Now we have the 5 square here. So this will be 6e over 25. Okay. Then we want to find the dx dt, then dx dt, dy dy. So this will be the 25 over 6e times 2. So the final answer will be 25 over 3e. Okay, done. Okay, so that's all for question.